So at this point, our enemies are basically working. They have their hit knockback, applying the shader, they have their death state, and they have their wander whenever they aren't doing a hit or a death. But they have no ability to really interact with the player. And in a lot of platformers, when a character would run into your player, they would deal damage to them. So we'll try to implement that in this tutorial. Also, one thing that I do think we should make a change on, if we go into the debugger for the Beehave tree, is that you can see that whenever the wander action is done, the selector composite restarts and it checks the death sequence and the hit sequence. But also in our code, we just check in here to see if we should interrupt the tick by returning failure so that these can go back. Basically, if the character's not alive or if there's an active hit on the character, then it would go here anyway. So we don't really need to be returning success when the timer times out. So what we could actually do is remove the return success so that this will never actually finish. It'll only be interrupted with a failure, or it will return running. So if we just do that, return running, we get rid of the is wandering variable, kind of like this, because if the character's in the wander action, he's always wandering. Then on timer timeout, we can just randomize the wandering, and then we restart the timer. So timer.start. Okay, and that's pretty much it. So if we hit play now, let's go to the debugger, we'll click on a character, and now you'll see that the wander action never actually leaves until we hit them and they leave their state. So that's going to just make the Beehave tree a little bit less annoying, where every half second it tries to check death sequence and hit sequence again. When that's really not needed, we can just keep the character in the wander action until something else interrupts it. So that aside, back to the player, there are a couple minor issues I'd kind of like to resolve. So one being able to jump. For the character, you need to go to the player scene. Make sure that can ground jump is checked on player stats so that your character can jump again. For the last few tutorials, I had it off. It must have reset back to the default of off when I moved it to the character stats script, which this is a child of. So just checking that should allow jump to work again. And also on the projectile, I'm bumping up the gravity scale from 0.2 to 0.3. That'll just make it so that the projectiles fall to the ground a little bit faster. So if they're too floaty, I don't super like it. I do like them to be kind of floaty. It's up to you, basically, what you want the gravity scale to be. If you have it at 1.0, then they'll fall like the player does. So that's one of the handy things about a rigid body 2D in Godot. You can just tweak the settings here and completely change the physics on how an object moves, which is powerful. And but you can just move a few sliders and change how things work, but also kind of tricky to debug because it's a little bit harder to know precisely how it's going to work just by changing the gravity scale. You don't know, for instance, will this be able to shoot up an edge? It shouldn't have been able to because the gravity scale is different now, for instance. Okay, so we want the player to be able to be hit. There are a couple ways you can do that. One would be to use a finite state machine. If you go into the asset library and you search state machine, there's a bunch of examples here that you can use. And then when your character is basically able to move and jump on the ground, you can make a ground state. When you want them to take damage and remove the ability for them to be hit, you can put them in a hit state and all of that. So we're going to do something similar, but because in our project, we're already using Beehave tree as a behavior tree for controlling our characters. Often this would be used more for AI, but I want to just take a crack at using it for our main character as well. So the idea will be that we do use a Beehave tree, and we'll probably use like play death action and play hit action, or these whole sequences really. But then rather than a wander AI, it'll be more like, okay, the character's in this ground state, and now we turn over control to the input devices like your keyboard or controller so that you move your player on the screen. So pretty similar to a finite state machine in some ways, and maybe a little bit overkill, but I want to have fun with it. So we will do a player behave tree. So in the player, let's go to the root and let's look for a behave tree. So the actor node path, I think this just defaults to the parent, so we probably don't need it, but let's make it like the invaders. So we have a separate blackboard. So we'll do that too, in case we need it. So blackboard, let's assign that in the inspector of the behave tree, like that. The actor is the player. Okay, so I guess no need to reassign that there. Tick rate 1.0. So I guess the idea here is if you needed to speed up an AI or a character, you could increase this or decrease it. I assume that's what that does anyway. We're going to process on physics. That's good because we're mostly moving the player. And now we just need to set up a tree. So I'm actually going to take all of this down to that and just copy that and paste it into the player. So the isDead condition, whether it's a enemy or a player, it's basically going to be the same. We just want to play the death animation when the character dies, and we just want the character to be hit, maybe apply the shader whenever the player gets hit as well. We could change the shader that we want to use here, so it doesn't have to be the same between enemies. But then the wander action, that's where things are going to differ. So basically, whether the character's in the ground or the air, we might change its controls a little bit. But then down here, basically, we are going to turn over control to the player or the player input. So we might even have like a ground player input action rather than the player input script that's always on over here. So let's actually create that ground player input. I'll right click on child node. Let's expand over here, leaf action leaves. We'll just have a standard action leaf here initially. I'm going to rename this to ground input action. And then let's extend the script. So it's going to be ground input action on player, create. Okay, and if I take a look at behave node, it extends nodes so it can have all the same input. So it can have all the same features as a regular Godot node. So if I want to, I can go into player input and I can take this unhandled input and we can put this into the ground input action. And then we just limit it so that the ground input actions are only going to be activated while the ground input action state is active. Let's start by just copy and pasting this over. I'll give it the class name ground input action, which is going to give the player controls for the ground state input. So the character's on the ground, this is what it can do on the ground when everything else is freed up. Okay, we don't need the wander action from the Beehave tree, that's for enemies. So just to get the function names, I'm going to look at the play hit action for a second. So we're going to have before run or active run to enable the ground input, and then we're going to have tick to set the movement direction while we're on the ground. So let's get that over here. Basically, function process is going to be replaced by function tick. Yeah, so it needs to return true or false. So this is just going to return running. And then we need the before and after. So the before run, just going to return void. I'll pass that for now. Let's copy this. We'll have the after run. Okay, and on before run, we're going to activate. And then after run, we're going to disable. So var active equals false. Before run, active equals true. After run, active equals false. And then before we do any unhandled input, we're going to check if not active, return. Okay, so that basically means that jumping and doing try shoot is not going to work if this state is not active. So we'll try with that for right now. This is probably going to need a little bit of tweaking. But let's actually remove the original player input for now. And I'll try hitting play and we'll see if this works at all. So player direction. That would need a reference to the actor. So this would be actually actor, actor.direction. So we actually need the node now. I think on before run, we could just get reference to the character. So player, it's going to be a player, yep. And then we'll say before run, player equals actor as player. So we'll get rid of that little underscore there because we are actually using it. And then we'll say player.direction down here equals this. Okay, and then we don't need to export for the player because we're already getting that from the actor. Okay, now let's click on the ground input action. We'll assign the shooter and the actions, player input actions from the project. Let's try hitting play and let's see if this works. Okay, so the character is able to move, the character is able to shoot, and let's make sure that we're actually in that state. So if we look at the player's tree, you can see that ground input actions is running, and basically it works exactly like it was before. Okay, now for our player to actually take damage, play a death sequence and play a hit sequence, we're going to need a setup similar to the invader, where we have a health component and we also have a object blackboard setter. So I'm going to copy and paste those over to player, health component for the player, and object blackboard setter. I'm going to copy that over to the blackboard down here. And let's move the blackboard above the behave tree. Now we can click on object blackboard setter, assign the blackboard, assign the health component, and we need a hurt box. If we click on the health of the player, well, we'll see this is using invader stats. We want to change that to player stats. So you'll be able to customize how much health a player has here if you need to. And then I'll be using that instead. So we need a hurt box for the player. So let's right click on the player. I'll add a hurt box. And then let's right click on hurt box and add a collision shape 2D. Let's make it something like a small sphere. Maybe a circle shape or a capsule shape. Let's make sure that the player is in the run state so we can see where we're putting the collision shape, and I'll hit W to move it. Let's put it up there. I'll hit Q to grab these handles at the edge and shrink it down. So maybe I'll make it a little smaller than the collision shape for right now, I guess. And I'll rename this to be hurt shape 2D. If we click on the hurt box, let's assign the health and the body, which is the player. And now on the object blackboard setter, we want to assign the hurt box. Okay, now for the player to get hit by the enemy walking into the player, we would need the invader to have a hitbox that is always on. So let's right click on invader and I'll add a hitbox 2D. Let's move that under facing, I suppose, just in case, so that it's always facing the right direction. And let's see, weapon stats. We do need to set like how much damage it should do with that. So I can do new weapon stats, and let's save that as objects, characters, enemies, and we'll say invader collision underscore stats.tres. Inside of that, 10 damage, and maybe we do want a knockback, so I say new knockback stats. I'll say 50 force. Why not? Okay, and then we can close that. So our hitbox needs a collision shape, so add in a collision shape 2D for the collision shape. Maybe we want like a box in it to only hit whatever it's facing. So by default, we're facing the right. Sure, we'll try that. So new rectangular shape. Let's move it to the right side. And I'll shrink it down, hit Q to go to basically handle selection mode. And let's make it kind of favoring the player somewhat. So right around there, we could even make it like a capsule shape. So I'll change that to a capsule shape and shrink it down like this. Q to go there. Okay, now I think that matches like the curve of the character a little bit better. If I move it over just a tad, then I think that's pretty good now. I could shrink it a little bit. Maybe I put it there and shrink it. Okay, sure. We'll go with that. Let's rename this to be collision hitbox shape 2D. Okay, now if you hover over it, it's got a really obvious name. Okay, and we have the hitbox. So this is going to deal 10 damage with a 50 knockback whenever it collides with something that it can hit. So we want to expand collision and make sure that this is going to mask out for the player only. So this will only hit the player, and it doesn't really need to have a ground. It doesn't really need to have its own layer because this is more of a look only box. In fact, you could even turn monitorable off if you want, because with a hitbox, nothing's looking for the hitbox. The hitbox is looking for hurt boxes, but it's not really necessary to toggle it off like that, though you could. It should be fine. So let's hit play and let's see if the player can get hit. I'll walk into an enemy. Okay, nothing happens. All right, so let's find out why. First, I'm going to check the player, and we'll check the hurt box. Let's make sure that the collision here is on player layer. It's not, so we need to make sure the hurt box is on the player layer. Doesn't need a mask, so it should just be player 2. So let's try that again. I'll run into an enemy. Okay, we don't get hit. So I'll try setting a couple breakpoints. In Hurtbox, let's set one here for when we get hit, and then in Invader Hitbox, let's go in here, and let's see, Hurtbox.hittable. Let's set one here. So basically, if it passes being able to get hit, it should create a hit data. We'll see if it gets there at all. Okay, and we did hit a breakpoint, so let's see what happened. The hurt box, if we open this up, should be the player hurt box 2D. Okay, that's good. That's what we expect. Then we go down to the next line. We're going to get hit. So hit actually does happen, which is going to emit was hit. Okay, and we have the old health. The actual change was 10. So if we look at the health component, we should see 90 health. So the player's taking damage. It's still alive, so that's good. It's just that the behave tree is not actually triggering properly. Okay. So if we close and get rid of all the breakpoints, I think I know what's up. If we check the player, we have the ground input action. As we just set it up, it always runs and there's no interrupt for this. In the invader, what we did is our wander action, we just check for a is alive or is instance valid hit data, and then we return failure. But there might be other conditions we add into our code where we would want to interrupt, and that would mean that we'd have to keep editing these scripts every single time. And that might not be optimal. So if we go to player and ground input action, I'm thinking that maybe what we need to do is add in the interrupt function. So if we do interrupt on a P actor, or really I'm going to underscore that because we're not going to use it for anything. So underscore P underscore actor and then underscore P blackboard. Type blackboard. This returns void. So the only thing we're going to do is set active to false. And if the tick occurs, but if not active, then we're going to return failure, let's say. It could also be success, but I think failure makes more sense since we're trying to break out of it and stop using it. So that means we need something else that's going to set the interrupt to occur. And as you can see, the interrupt is going to require us to do a actor and a blackboard. So we could just call this from any script and then set these to false, but maybe we do want to pass those in. So to actually trigger the interrupt on our ground input action, we may want a secondary script that can target a action and call the interrupt on it. So there's probably a handful of ways you could do that. One could be to have a parallel action running in addition to this, which can just basically, in response to hit being set, we trigger the interrupt on the ground action, and then we can separate the code for the interrupt from the condition itself and reuse that for other things. So I'll right click on the selected composite, add child node, and let's do a simple parallel composite. I'll put the ground input action there. And then let's right click, add another action leaf. So basically with a parallel, these two will run at the same time. And I want to say interrupt on hit action. Let's extend that script. I'll put it into, let's just say objects, open, create, give it the class name interrupt on hit action. I could put the interrupt code on the tick function of an action leaf so that every time it ticks, we just check if the hit data exists. But that's quite a lot of checks to do that on every single physics frame. So what I might do is just say before, or let's see, function before whatever it's called. Hold on. Play hit had after run, so it's before run. Okay. So before run, we're gonna get the actor, which is a node, and the blackboard, which is a blackboard. This is gonna return void. And we want to get a reference to, let's say, the hitbox. For our game, at least at the moment, there's only going to be one hitbox. So, but you know what? Maybe it makes sense to actually add an array of hitboxes. Maybe you have an enemy that is going to have 6 hitboxes, and you want any of them to interrupt an action. So we could say at export var hitboxes, which is going to be an array of hurtboxes, hurtbox 2D, an array of hurtbox 2D. So hurtboxes, and before the run, we want to connect to all of their signals. So for hurtbox and hurtboxes, we're going to take hurtbox.wasHit. We're going to connect to it with its onWasHit. And then function after run, is that what it was? Hold on, play hit action before run, after run. Yeah, okay. Then we're basically going to copy this up there. We're going to disconnect from the signals. So we can actually just copy this over here, make that a disconnect. Okay, now we need to create the function on wasHit, which is going to have hit data, if I remember right. And what we want to do is we want to interrupt the target node. So at export var target action, we're going to get an action leaf. And on that, we're going to pass in the actor and the blackboard. So target action.interrupt, and we need the actor and the blackboard. I'll get reference to those before run. So var actor, var blackboard. Actor equals p actor, and blackboard equals p blackboard. So now we can go ahead and remove the underscores there because we are actually using those in this function. We pass in the actor and the blackboard just in case we need it on the interrupt. So the advantage here is that this code is never going to run until one of our hurt boxes actually triggers its wasHit, and then it's going to interrupt the target action. So we assign the target action, which is GroundInputAction, and we add in a hurt box, which is our hurt box 2D for the player. And hopefully that's enough for that. We should implement the tick function still, I guess. So function tick, which is going to be p actor node p blackboard. It's going to return an int, and this will just always return running, I think. So if I understand simple parallel composite, if the main action, the ground input, returns false over here, returns failure, then this is going to stop too. So basically, it's only going to be doing the interrupt checks while this is going. We can test by setting a couple breakpoints. So let's see if this ever gets to there. I'll hit play. Let's run into an enemy. Okay, we got the interrupt action to actually trigger. Let's hit play. And as you can see, it's going to the set shader action, which is under the hit sequence. So we just need to make sure in set shader action, we assign the canvas material, which is our animated sprite. Let's go to the remove shader, set the animated sprite, and does the player hit action need something? Yeah, it needs the animated sprite. Let's hit play and let's see if we can get that knockback. Okay, yeah, as you can see, we lose control over the player while the hit knockback is occurring. And the player can also die if he took too much damage. I think what happened there was that there was like no invincibility frames either, so we'd probably want to set something like that up, but we need to go to the death sequence for the player and assign the sprite, animated sprite. We can kind of see that on all of these play death actions and set shader actions that we need a reference to the animated sprite 2D. That's going to be quite common. So what we could even do is on our player platformer character body 2D, maybe just on the platformer character 2D, we have a reference to the sprite. So at export var sprite, which is going to be a canvas item. So we'll call it a sprite, but it's really a canvas item in case we need to use something that's not an animated sprite. And let's assign the animated sprite here. So what we'll be able to do in all of these actions is remove the export. So we don't need to manually do that. And then we just do actor.sprite.play, actor.sprite.play, or .animation finished. Yeah. Okay, now this does kind of make the assumption that there's a sprite property on the actor. But if that's consistent across all of our characters, that should work fine. Now we can go to the other actions like set shader action, and we can just do actor.sprite.material and get rid of the canvas item reference here. And on play hit action, we can also get rid of the sprite reference here and just do pactor.sprite.play animations. And yeah, that just reduces the amount of assigning in the inspector we have to do. So if I have that set up right, it should work the same way now. Yep, you see we just get reference to that sprite, whatever it is, whether it's a regular sprite or a canvas animation, whatever. If we check in the debugger now, there's no animation named hit. Yeah, that's probably one of our issues. So let's go to animated sprite 2D. I'll create a new animation. Let's call this hit. I'll get the frame from here, copy, and just paste that into hit. So it'll be the character facing forward as our hit frame. Let's hit play. We do want to make sure run is the default. I'll hit play again. On the ground input action, we do want on before run to tell the sprite to play the run animation. So pactor.sprite.play, we'll say global names.animations.run, let's say. Okay, and we can make sure that's a real name by going lookup symbols, lookup symbol, and then do export var run, string name equals run. You can also set a default for idle. We probably need that later. So string name equals idle. Okay, now let's hit play. Let's see, we got the run animation going there. If we hit a guy, okay, it plays the hit frame. Yep, it goes back to running. But when our character's not moving at all, we should actually change it to idle. So on ground input action, I think we should default this to idle. And then on tick, we can check if the character's moving. If so, we're going to play run. Otherwise, we're going to play idle. We could say something like if player.velocity.x equals 0, then we're going to play idle. Otherwise, we're going to play run. Now, having this run on every tick might not be the most efficient. Player.sprite.play, since we already have that reference. But we can give it a shot. It should work for now. So as you can see, if our character stops running, then we just play that one frame. But you know what? I don't like that as the idle frame. That doesn't actually make a lot of sense. So let's actually just stop the animation if he stops playing. I think that makes sense. Okay, so up here, we'll play run. And then if the velocity x is 0, we're just going to tell it to stop. So that's something an animated sprite can do. Let's see, it does have a stop animation. It does have a stop method, so we can use that. So just tell it to stop if it stops moving, otherwise it's going to play the run animation. So now our run looks more like that. And if we get hit, we play that kind of sliding knockback, or we lose control. Obviously, it's kind of like too strong, and now we've completely lost control of the character. Let me see where we get at. There's no animation with the name death. Okay. So we can go to our animated sprite, click in there. This should be a death animation. So death. And if we look at the interrupt on hit, it was already connected. So let's jump into that. We might not even need to make it a before run, after run sort of thing. We could actually make this maybe function underscore ready. And that's where we're going to do this. On before run, we get a reference to that. No need to disconnect on after run. And I think this is only going to actually interrupt the action if it's currently going. So we'll try this. And then that should clear up all those errors. So let's get hit. Okay, we get hit a few times and we're not reconnecting the signals. So it's all good. We still got our sliding knockback and our character just slides. And we do need to make sure that death does not loop so that he gets removed from the scene. If we want to make the death a little bit longer, though, we could duplicate the frames a bit. So maybe 3 frames of death, so it's like 0.3 seconds. And let's make all of the FPS 10. 10 FPS, 10 FPS, 10 FPS. Okay, we'll hit play one more time. Let's get hit a bunch of times. We'll take damage, and our guy dies and fades from the scene, and that would probably be where we play a game over. So a Beehave tree is working as intended. There are some things that need to be cleared up, like first off, game over screen. Second off, probably invulnerability frames, and reducing the force knockback. So we'll work on that kind of stuff in the next video.